Right, so we're in the next bit of it. Networking concepts. And we didn't get any new stuff because they were one of these and one of this that we already have. So we'll just have to continue having fun doing the rooms. So networking concepts. Learn about the I was sigh. Yeah. So I've already done rooms on that, and I've already done like a university course on that long ago. Have you ever wondered why you need an IP address to access the internet? So I don't think it's worth it anything, the OSI model. So true that an IP address can be cleared by a user. So this is just like some kind of introduction. So there are like no, this is just what rooms are coming. I was thinking, do we need to have these before, No, it was just the pre-security path. OSI model. Who is happy about the OSI model? So before we start, we should know that the OSI model, it's not like it's bad, it's just that, well, TCP/IP itself is better, of course, but yeah. It's just that the focus of studying it, that's what I'm against. So it's a model of conceptual developed by the ISO. Describes how computers should occur, and it's also older than TCP/IP, I think.
Study for Security Plus says.
Layer 8 is where all the problems are.
Yeah, right. So, physical, application, and user. The numbering starts with the physical layer being layer 1. So, please do not throw spinach pizza away. This kind of, that they're using spinach pizza here, it's kind of like, that's how I feel about the OSI model. Like spinach pizza. It can exist somewhere. I don't care. I just don't want to touch it or eat it. So the layers are, they're, if you talk about switches and stuff, of course it's, but you could just talk about the actual things instead, right? So is it better to say network layer or layer 3? This is just keeping people out, making it sound more advanced than it is, right? So here is the physical layer. We don't really need more of this information here. There are ones and zeros. They go through different media, Wi-Fi. Data link layer. Physical layer defines a medium to transmit our signal. The data link layer, layer 2, represents a protocol that enables data transfer between nodes on the same network segment. Let's put it in simpler terms. A data link layer describes an agreement between 5.5 hours. How did that happen? So, at least my body's in better shape now. So, where were I? A segment refers to a group of network devices using a shared medium or channel for information transfer. For example, consider a company office with 10 computers connected to a network switch. That's a network segment. An example of layer 2 includes MAC addresses, media access control. So here's a MAC address. We expect to see 2 MAC addresses in each frame in real network communication over Ethernet or Wi-Fi. The packet in the screenshot below shows. So, source and destination MAC addresses here. So I think it shows it slightly bigger when I click, but not usefully much. Then the network layer. I guess I'm reading it all. The data link layer focuses on sending data between two nodes on the same network segment. The network layer, layer 3, is concerned with sending data between different networks. In more technical terms, the network layer handles logical addressing and routing, i.e. finding a path to transfer the network packets between the diverse networks. So this has really not been saying anything. So when I read things like that, I always want to make my own information instead for people. In the data link layer, and I'm not saying I'm an expert on this, I just thought there were several sentences that didn't say anything. In the data link layer, if you gave an example of one company, office with 10 computers, they could have just said, in the example, they're the data link layer. I'm annoyed at long text, okay? So I have to make it look the same amount of text in all the sections. Better put some extra texture. In the data link layer, where the data link layer is responsible for providing a connection between them. Let's say that this company has multiple offices distributed across various sites, cities, countries, and even continents. The network layer is responsible for connecting the different offices together. The network below shows that computers A and B are connected, although on different networks. You can also notice two paths connecting the two computers. The network layer will route the packet through the path that seems better. It deems better. Examples of the network layer include IP, ICMP, VPN, IPsec, SSL, TLS, VPN. VPN protocols such as. Now they're minimizing the text. They got tired and no images anymore. Transport layer. The transport layer enables end-to-end communication between running applications on different hosts. I think I know why too, because now they didn't have any TCP/IP good examples, right? Oh, well, in the part they do. So, I'm sorry, I need to just stretch a bit. Trying to sit in a good way instead of just in an odd way. So, yeah, that's the GitHub where I have my notes. So, for our transport layer, enables end-to-end communication between running applications on different hosts. Your web browser is connected to the TryHackMe's web server over the transport layer, which can support various functions like flow control, segmentation, and error correction. Examples are TCP and UDP. Session layer. Session layer is responsible for establishing, maintaining, and synchronizing communication between applications running on different hosts. Establishing a session means initiating communication between applications and negotiating the necessary parameters for the session. Data synchronization ensures data is transmitted in the correct order and provides mechanisms for recovery in case of transmission failures. Examples of session layers are NFS and RPC. Presentation layer. So soon we're at the application layer. Presentation layer ensures data is delivered in a form that application layer can understand. Layer 6 handles data encoding, compression, and encryption. An example of encoding is a character encoding, such as ASCII or Unicode. This is like such a tiny layer, right? Various standards are used in the presentation layer. Consider a scenario where we want to send an image via email. First, we use JPEG, GIF, and PNG to save our images. Furthermore, all hidden from the user by the email client. We use MIME, multipurpose internet mail extensions, to attach a file to our email. MIME encodes a binary file using 7-bit ASCII characters. Layer 7 application. Layer 7 application layer. The application layer provides network services directly to end user application. Your web browser should use HTTP protocol to request a file, submit a form, or upload a file. The application layer is the top layer, and you might have encountered, if we don't talk about layer 8 then in a sec, you might have encountered many protocols that use different applications like HTTP, FTP, DNS, POP3, SMTP, IMAP. Don't worry if you're not familiar with all of them. Summary. And there's the summary. I don't think I have a note in OSI, do I? Should I have a note in OSI? So I have a Windows notes, I have Linux notes, I have hacking notes. Do I have like networking session? I don't think so. So maybe we'll add a new, almost empty one, right? Because I don't have any theory about networks. So let's make a... Right, it needs to be out here. Network. So we're going to move it. Where did it hop to? Yeah, so this is not actually in... Come on, you can scroll. I know you learned how to Obsidian. I know you know how to now. There, and then we should have it side by side by Linux. And let's make it side by side. So, in case anyone reading my notes wants this table, I'm just putting it there. That's all you ever need to know, right? So we could really have skipped all of the other text and just read this. Oh my goodness. Yeah. So I was not thinking of that. We will of course get questions too. So, Whistler encoding the application data. Whistler response or transferring data between hosts on the same network. So we could have just had what digit here, right? Instead of having to say layer for everything. So I'm going from the bottom, layer 2, and then we had layer 3. Layer 3, and then we have that was application, so connecting one application to another, and so this looks like encoding application data would probably be 6. We could use look at what words they were using. Yeah, they were using encoding for layer 6 too, so. And so I'm thinking 7 there. Did you see that? It changed it. It changed it. That's interesting. What's the hint for this? The answer should be layer followed by a number, for example. Yes, I didn't write for. application to application, I was thinking, because it goes, up and then goes down. So I wrote 7 and it changed it to 4. That's interesting. I've never seen that before. It's like lower and uppercase, it just fixes it. Or this is what I was talking about, layers. So now we have the TCP/IP model instead. So this is more useful. Now that we have covered the conceptual ISO-SI model, there's time to study an implemented model, an actual useful things, TCP/IP. And did it say what year this was? So I'm sure it's after TCP/IP already existed. So I don't know why they did that. So let's just find up some extra layers that we don't really use, but we just think that this is nice to add some more theory for all our students to learn in school. Or something. So this course is too easy, we have to add some stuff. No, but it's ISO, they made it, I don't get it. So maybe they thought things would evolve, and there needed a best standard for it. So, in our presentation of the OSI model, we went from the bottom to the top, from layer 1 to 7. In this task, let's look at things from a different perspective, from top to bottom. From top to bottom we have top to bottom. Sorry, it's the editor in me that wants to fix stuff. Application layer, the OSI application model presentation, and the sessions layer, i.e. 5, 6, 7 are grouped into application layer in the TCP/IP model. And still they had TCP/IP examples in this one, right? Well, I guess 6 is really just format. Yeah. Well, let's continue. So, let's actually make a TCP/IP model node and just copy the same table. So we have that mentioned in our notes. We might actually put in other stuff here later. So let's do TCP/IP. Yeah, it will not handle that since it's a file name. Well, that's a bit. I like that it's files, but it's annoying when you can't use slashes. And some other characters too, like question marks, right? So let's copy the table. And let's paste the table. There. So. Many modern networking textbooks show the TCP/IP model as 5 levels instead of 4. For example, in the computer networking top-down approach, they have application, they have physical too. Yeah. So it's physical is like you don't need to mention it really, but maybe you should, kind of thing. Which layer does HTTP belong to? So it depends if we start on 0 or if we start at 1. So I'm thinking of renumbering my copied table because they still have the layer numbers of the OSI, and this node is actually called TCP/IP. So let's just delete these. And let's put this on 5. And let's keep the physical there. So I can agree that physical is nice to have. So let's have these application transport, network or internet. So they have switched it here too, because internet layer, network layer. So to which layer does HTTP belong? Oh, they want the name of the layer. So nice that I have easy to copy from. So how many layers disappear? Does the application layer cover? 3. So IP addresses and subnets. Okay, so I might skip stuff here. If they don't mention a lot of IPv6, because that would be interesting. So I don't want to like spend all day on reading stuff that's looking at pure network configuration. IP, yeah, so IPAS show. Never done show. They also have to try what the difference between adding an S and not adding an S there is. The terminal output. So private addresses. Routing. So it's explaining as if we never seen an IP address. Which of the following is not a private address? So I guess it's the 1021. No, it's not, of course, because 10 is the whole darn thing. So this is 16 to 31. Yeah, so it's in there. So it is this one. Just confirming that I'm not like... We could really have seen it easier, I guess. So Windows uses these a lot, so you shouldn't use those. Which of the following IP addresses is not valid? 305. Okay. So we only go to 254, right? We need 0 too. Well, this is kind of odd that with 0 and 255. It seems to work differently, different times. So UDP TCP, I guess that we will read this. But we can answer the questions first. Approximate number of ports. Okay. So the IP protocol uses. So we have UDP, which is not as safe checking, right? Connectionless, simple. Do not need to establish a connection. It just sends data. No idea if it reaches where it's going. We have port numbers. Real life example. Standard mail service with no delivery confirmation. No guarantee UDP packets have successfully been received. It's like sending a post packet without confirmation of delivery. Better speed. No confirmation. So TCP, connection oriented. Instead, the opposite. Layer 4. Being connection oriented, it requires establishment of a TCP connection. Before any data can be sent in TCP, each data acted as a sequence number. It's easy for receiver. Yeah. 3-way handshake. Since and a It didn't say much here. We already answered the questions. Let's go to the next one. Before wrapping up, it's crucial to explain another key concept, encapsulation. In this context, encapsulation refers to the process of every layer adding a header and sometimes a trailer to the received unit of data after sending the encapsulated unit of layer information. This is more interesting. I mean, it's how they should have explained the first bit. Application data. It all starts when the user inputs data they want to send to application. For example, you write an email or an instant message and hit the send button. The application formats this data and starts sending it according to the application protocol used. Using the layer below it, the transport layer. So we have the application data. Then transport protocol segment or datagram. So this clicks again. I'll see if I can make it stop. The transport layer, such as TCP or UDP, adds a proper header information and creates a TCP segment or UDP datagram. This segment is sent to the layer below, the network layer, so it goes down another layer. The network layer, i.e. the internet layer, adds an IP header to the received TCP segment or UDP datagram. Then the IP packet is sent to the layer below, the data link layer, meaning the physical stuff, right? Or rather, not the physical, but where were I? The data link layer. The Ethernet or Wi-Fi receives the IP packet and adds a proper header and trailer, including a frame. So we need this bit too. I skipped one there. It's just because we don't have the last one. We start with application data at the transport layer. We add, oh, they're doing it again. Okay, so they're just repeating. So Ethernet, Wi-Fi header, there too. The process has to be reversed on the receiving end until the application data is extracted. The life of a packet. Based on what we have studied so far, we can explain a simplified version of the packet's life. Let's consider the scenario here where you
Asoa says hello.
Hi, hello, welcome in. Hope you're good. So, on the TryHackMe search page, you enter your search query and hit enter. Your web browser using HTTPS prepares an HTTP request and pushes it to the layer below, the transport layer. The TCP layer needs to establish a connection via the 3-way handshake between your browser and the TryHackMe web server. After establishing the TCP connection, it can send the HTTP request containing the search query. Each TCP segment created is sent to the layer below it, the internet layer. Or the network. It says both in different parts of this room. The IP layer adds the IP address. Now it calls it IP layer to your computer. Let's make it not confusing for new people, right? Your computer, the destination IP address. Though IP layer would be kind of nice, right? Let's call it just the IP layer from now on. The IP address of the TryHackMe web server. For this packet to reach the router, your laptop delivers it to the layer below the link layer. Depending on the protocol, the link layer adds the proper link layer header and trailer, and the packet is sent to the router. And all of this is much easier to see if you just look at Wireshark or something, right? I mean, not exactly like that, but like this. Where's the handshake? Right, and those things. So it's like it's not complete. It misses stuff here. So it's doing the handshake between going down the layers. That's what I mean. Depending on the protocol, the link layer adds a proper link layer header and trailer, and the package is sent to the router. The router removes the link layer header and trailer, inspects the IP destination among other fields, and routes the packet to the proper link. Each router repeats the process until it reaches the router of the target server. The steps will be reversed as the packet reaches the router of the destination network. As we cover additional protocols, we will revisit this exercise and create a more in-depth version. Okay, so there will be more. On a Wi-Fi. Yeah, this is like, I guess this is a good introduction, right? If they didn't know anything of it. This is the datagram stuff and all that. Did we have that easy somewhere? It was actually up in the last one, I guess. We had questions there too. Yeah. So segment or datagram. Whatever. Oh, it changed it. So several answers are correct, and they changed it to a standard one now. The changes the case. As it changed my layer up there to another one, it also wanted to be the primary one apparently. In Wi-Fi, well then what will an IP packet be encapsulated? On a Wi-Fi. So what do they mean? Okay, so it's this layer there. So we have 5 letters.
VR Mechatronics says.
Hey, how is going?
Yeah, it's going good. How are you? Everything good? So what do they call this? Frame. Yeah, they're calling it a frame. So to have these words.
Next 15 minutes I have go gym.
Oh, nice. Good luck at the gym. So we actually had a start machine down here. Nice. So telnet. So we're going to play with telnet and test stuff on ports. I use telnet. What's the name of the version of the HTTP server? Okay. So it sounds like a bit odd to have this tiny thing to connect. But thinking this is a very basic room, I can understand it. So we'll have to wait a minute. So telnet we can like connect to anything. Yeah, we can use to connect to any. On the virtual machine, different services of them are running. Echo server echoes everything you send. We'll see the ports. Well, we don't need to scan it now because it says the ports. Daytime server. Replies with current date and time to what? We'll see. And the web server, port 80. Before continuing, we should mention that the Echo and the daytime servers are considered security risks and should not be run. However, we started them explicitly to demonstrate communication with the server using telnet. And telnet also means not encrypted stuff, right? And HTTP too. We connect to the target VM with the Echo servers. Yeah, so we're going to do this. We don't have to read. Then port 13, and let's see. Connected. Escape character. Will it just give us this and disconnect? It looks like that. Finally, web page. You need to issue a command like get. So we'll just do these things. We have an IP. I'm just trying to finish my cheese. Oh, right, so the last one is still on because it starts for 2 hours, and I think we were finished much shorter time. Oh, this is so good. And my tummy's not complaining either. I'm sorry, we have a cheese break. Baby bowl. Also, that's my dinner or something. So, where did we have the connection information? Right. I'm so used to SSHing. We're not actually doing that now. We're going to do telnet. So, telnet, and we have 10, 10, 150, 250, and the first port was 7. So, test, echo, quit, exit, yeah, so is it totally locked? So, whatever. Okay. Let's just open a new tab and close that one. Bye. So, no. Right. Let's open a new one again, because I just want to have the history there of the telnet. And then we have 13. This is supposed to be the time, right? So we can do the time, and we get the time several times. And the next one is 80 for HTTP. So now we're going to have to type stuff. So let's send. Oh, nothing. Right, I probably wasn't clicking correctly. Now I'm there, so let's do get HTTP 1.1. Why did it say host telnet? Sure, host telnet .thm, and so let's see, there's questions. They want us to paste this, of course, right? But there's also the version here. This one too. So let's paste this one too. So in this room we covered now that you're finished, this will be the next room when we click complete. So here are networking essentials. So what tickets will we get? Oh, this is the second DEFCON ticket. So I think they might be out. I don't know. If we get a third one, I will be very curious to see if we'll actually get anything. So it's kind of slow there, right? So now we have 2 here too. It seems like it's making 2 of everything though, right? So getting the last one is really the thing. We'll have 2 of everything. We'll see. So anyway, that's the best one to get. Not that I don't mind a laptop. But that's kind of more of a personal choice thingy.
Web link.
So I don't know if I dare to open links.
Looks good.
So let's click it. Don't know what it is. So I can look later. So let's put it in the to check after stream. So I think my resources on my computer are not that unlimited. So we'll save them. What is it? VR. So you can tell me, Explore networking protocols from automatic configuration to routing package to the destination. Introduction. Have you ever wondered how your computer can dynamically configure its network settings? Oh. Okay. Have you ever wanted to know when devices and countries your packets pass through before reaching their destination? Are you curious how all your home devices can access the internet even though your ISP gives you a single IP address? Okay. Yeah. So this is for people who don't know anything about networking, so I shouldn't be like... So... we recommend that you know the following. So I would probably not have done these rooms if they were not like getting me tickets, right? So now we're doing these, and maybe it's a good reason to do them because there might be things in there that I want to know, or even might just want to add to my notes. Now I didn't close the last one room either, and we just started it. So I'm just exiting. Let's see. I'm getting a new one up there. So we have a fresh terminal on Kali. So you went to your favorite coffee shop. So, whenever we connect our device to a network, the above configuration must be set. Or to have a new network, manually configuring these settings is a good option, especially for servers. I guess. Should I read it all? Having an automated way to configure connected devices has an advantage first. It would save us manual configuring. Good for mobile devices. Or your ESP cams, right? It's kind of hard to, well, it's connected like this here. So, good to have DHCP when you're connecting this. It's DHCP. It's an application level protocol that relies on UDP. The server listens on UDP port 67. And the client sends from UDP port 68. Your smartphone and laptop are configured to use DHCP by default. Yes, let's make sure these are in our notes on ports. That's as far as I go on notes on this. So, ports. Where do I have ports? Network exploration, maybe. Yeah, right. So here we have port use. So let's put them in here if they're not already here. They're already here. So let's add a comment saying DHCP server. Let's split it up instead. Right. We don't even need that. We just need so many letters to copy, right? Lessons on DHCP client. Lessons on your smartphone and laptop are configured to use DHCP by default. DHCP has 4 steps. Do I have notes on DHCP? I have lots of protocols actually, so maybe we should just add DHCP here. It's definitely on network explanation. Exploration. So let's add DHCP here, and let's just so I'm also copying so, and I'm adding a note there that this is from TryHackMe, meaning I'm going to edit this to make it better, but I don't want to like read it all carefully now and edit it. Is a client broadcast DHCP discover message seeking the local DHCP server if one exists. The server responds with a DHCP offer message. The client responds with a DHCP request. Indicate the message is accepted. The offer is IP. And with this one actually, it got 2 different DHCPs, and every time it starts, it's like random which one it gets. So it's very odd. I've never seen that before. It would be interesting to look at the traffic. Right, let's see. So, we'll look at that later. The server responds with the DSP pack message confirming that the offered IP address is now assigned to the client. What a server. I don't think this is usually what does DSP. The following packet capture shows the 4 steps explained above. In this example, the client gets the address. Oh, this is nice. I told you there would be something interesting in here. In the DSP package exchange, we can notice the following. The client starts without any IP network information. It's just empty. It only has a MAC address. I need to switch ears again because it's just crackling on this one. So the left one, it's like broken. So how much power? Adjust the low. Okay, it usually says power level 2. It's time to start doing TryHackMe. So we have to stop this and do some TryHackMe, right? Yeah, so here we can see the new. Oh, we can see more than like just 3 or 4. We can see the whole section. And we have also Wireshark here. Yes, I think these are new rooms. Let's actually look at this one. See what time, days, 1 day ago, right? So these are new rooms we're doing. So that's why it's a bit fun. Users in room 891 in 1 day. So, yeah, I like this. So, but I want lower level even than this. But I'm thinking of copying this. So if I were to just copy this to the nodes. No? Oh, let's do that. So why did it add lots of tabs and stuff? Ooh, gosh, you got it, I got it. It just mangled everything. The line breaks and stuff. So I touched 4, 1, 2, 3, 4 spaces. And then we do a new line there. And oh gosh, that was 1 arrow down. New line. So 1, 2. There. That's as good as I can get it. Maybe I can make it a bit better. Yeah, let's. Oh, yeah. So I was thinking I was going to drag this one a bit to make it better looking. So the client starts without any IP network configuration. It has a MAC only. Of course, it doesn't have an IP. So sends from 0000 to the broadcast address. Right. As for the link layer, in the first and third packets, the client sends to the broadcast MAC address. So first and third packets, not shown in the output above. The DCP server offers an available IP address along with the network configuration in the DCP offer. Yes, I really want to play with Wireshark now. I haven't really looked at this, and I'm very curious to see the communication that happens when this one gets different IPs. So As it is totally shut down, it will not remember anything, right? But the server will remember that it gave this device an IP. Or the firewall that's giving IPs here. As for the link layer, the first and third packets, yeah. This proposed IP address. I'm sorry, I'm pausing to get something more to eat because my tummy is not totally happy really. How many steps does DCP use? So I think it means the 4 steps, because otherwise it would be more complex, right? What is the destination address that the client uses when it sends a DCP? So we're going to copy the 255s here. So too much to write. What is the source address that the client uses? So I know that it's usually like, well, if they have to have a question, let's have these questions, okay? I'm not satisfied. At the end of the DHCP process, our device would have received all the configuration needed to access the network or even the internet in particular. We expect that. I'm going to put a link to this room in my notes there, because this is a tiny bit more of data here, and this is also the source of it. At the end, the gateway or router are packets. Oh yeah, the data. So it just mentions the lost room. Whenever our host needs to communicate with another host on the same Ethernet or Wi-Fi, it must send an IP packet within a data link layer frame. Although it knows the IP address of the target host, it needs to look for the target's MAC address, so the proper data link header can be created. As you would remember, a MAC address is a 48-bit number, typically presented in hexadecimal notation. Example. However, the devices on the same Ethernet network do not need to know each other's MAC address all the time. They only need to know each other's MAC address while communicating. Everything evolves around IP addresses. Consider this scenario. You connect your device to a network, and if the network has a DHCP server, your device will automatically configure to use a specific gateway and DNS. Consequently, your device knows IP address and DNS server and can resolve any domain name. Moreover, it knows the IP address of the router. Then it needs to send packets over the internet. In this scenario, no MAC addresses are revealed. However, 2 devices on the same Ethernet cannot communicate without knowing each other's MAC addresses. As a reminder, in the screenshot below, we see an IP packet within an Ethernet frame. The Ethernet frame header contains destination MAC address, source MAC address, type IPv4. In this case, I'm just, so bridging and where to, okay. So I read ARP only. Before, let's continue reading. So, Address Resolution Protocol ARP makes it possible to find the MAC address of another device on the Ethernet. So, Destination, source. In the example below, a host with an IP address 89 wants to communicate with 1. It sends an ARP request asking the host with the IP address 1 to respond. The ARP request is sent from the MAC address requested the broadcast address. That's the first packet. So ARP reply arrived shortly afterwards. The host with the IP address 1 responded with a MAC address. From this point, the host can exchange data link layer frames. So So I need to play with T# too, it seems. So ARP we have notes on, but not too much. Yeah, it's not a lot. It's really nothing. Let's just continue here. So I didn't copy it. I just had the room name in my copy buffer. So I'm just pasting this. Alright. There, I don't care that we're grabbing the lines. If we use TCP dump, the packets will be displayed differently. If we use it uses the terms ARP request and ARP reply. Who has tell? Who has tell? So what's the difference? So of course here we can see the MAC address. That's nice. And this should be from this one. Double like it. The ARP request to ARP reply is not encapsulated within a UDP or even IP package. It's sent directly in the Ethernet frame. So let's just copy this too. So let's actually put the other let's see here. So what I would like to do here is to actually have a machine to test stuff on. And this is just theory. There's a tiny view site at the bottom. There's no testing, there's no labbing, there's no doing this for yourself and learning. This is just looking at stuff. Looking at stuff is not good enough. I want to do, not look at stuff, right? This is what like watching TV. I don't watch TV. So I feel I'm like teased to. So I've looked at these packages in Wireshark, but now I want to know more. I want to use other tools. when I see the file there. So, ARP is considered layer 2 because it deals with MAC addresses. Others would argue that it's part of layer 3 because it supports IP operations. What is essential to know is that ARP allows the translation from layer 3 to layer 2. What is the destination MAC address used in an ARP address request? So we will just copy it. It was here. Am I blind? No. So, in the example below, this is a MAC address of 1. So, ICMP. Troubleshooting. But everybody has ICMP disabled, right? Internet Control Message Protocol, ICMP. Yeah, I have notes on ICMP too. So I'm going to copy this again and add some text from this. I'm sure they're saying something useful. We'll see. Mainly used for network diagnostics and error reporting to public commands. Ping and traceroute. The command uses ICMP to connect to target system and make sure the round trip time RTT. In other words, it can be used to learn that the target is alive and that its reply can reach our system. Traceroute. Traceroute. We read this traceroute on Windows too. It uses ICMP to discover the route from your host to the target. Ping. Yes, I have notes on traceroute actually. Yeah, that's just a tiny bit. So I probably have it in several places because that's not what I thought. That's what I had on traceroute. So we'll see if we have any ACMP stuff to add here. If there's anything juicy. Ping pong. Right, I know I have on the type somewhere in my notes. But it's not in my ICMP notes. Yeah, it's kinda is because so what link is this? So that's my source for that. So so it go. Yeah, because I was looking at the. I think it was debugging something. I don't remember. So computer response. There might be rentals from getting the reply. Yeah, we don't need to make ping notes. What shows the packet last more traceroute. Yeah, so I'm going to just hop to my traceroute notes again. Since datagram UDP datagram IP packets TTL of 1 and 2, right? Let's actually just put here that it's type ICMP type 11. Routed drops packet and sends ICMP. Type extend ICMP. Oh. Right. So it's not really 11. Let's just skip that. We can Google if you want to know more. There wasn't more information here. It uses an example image about how many bytes were sent in the echo ping. In the ping. 64. What? How many bytes were sent in the echo ping requests? 64 bytes? 64 bytes? Oh, they want us to plus them together. Is this a math thing then? Oh my goodness. No, that's not right. That's 3 letters. So did they mean this one? 60 byte packets. If this is 60, this is a bad question. Yeah, it's not 60. So using the example images above, which there's no images, right? How many bytes were sent in the echo ping request? And in the ping request, oh, these are images. Okay, now we're getting somewhere. So this one is 98 bytes. Okay, so I thought they meant these first. That's also wrong. So images, how many bytes were sent? Frame 1, this is the full thing. Protocol, type echo ping request, status, identifier, sequence number, timestamp ICMP data, data 40 bytes. So the data is 40 bytes. The whole thing was 98. So read the question. Which IP header, and actually I thought they were meaning this was images, seriously, because that's the way it usually is, right? Which IP header field does the traceroute command require to be 0? TTL. Routing. So it's not a lot of text here, I see. Consider the network diagram shown below. It only has 3 networks, however. How can the internet figure out how to deliver a packet from network 1 to network 2 and network 3? Although this is an overlay simplified diagram. So network 1, network 2, network 3, and we have the internet. Let's consider a more detailed diagram. So, internet would be millions of routers and billions of devices. The network below is a subset. It's not the whole internet. Why? The mobile user can reach the web server. However, for this to happen, each router across the path needs to send the packets via the appropriate link. Obviously, there is more than one path, a route connecting the mobile user to the web server. We need a routing algorithm for the router to figure out what link to use. The routing algorithms are beyond the scope of this room. We will briefly describe. So, oh, look at this, Okay, this is starting to look interesting. And then but this is out of the scope. So I'm going to do a quick bathroom break while we TTS this. I'll be right back.
The routing algorithms are beyond the scope of this room. However, we will briefly describe a few routing protocols so that you become familiar with their names. OSPF, Open Shortest Path. First, OSPF is a routing protocol that allows routers to share information about the network topology and calculate the most efficient paths for data transmission. It does this by having routers exchange updates about the state of their connected links and networks. This way, each router has a complete map of the network and can determine the best routes to reach any destination. IGRP, Enhanced Interior Gateway Routing Protocol. IGRP is a Cisco proprietary routing protocol that combines aspects of different routing algorithms. It allows routers to share information about the networks they can reach and the cost, like bandwidth or delay, associated with those routes. Routers then use this information to choose the most efficient paths for data transmission. BGP, Border Gateway Protocol. BGP is the primary routing protocol used on the Internet. It allows different networks, like those of Internet service providers, to exchange routing information and establish paths for data to travel between these networks. BGP helps ensure data can be routed efficiently across the Internet, even when traversing multiple networks. RIP, Routing Information Protocol. RIP is a simple routing protocol often used in small networks. Routers running RIP share information about the networks they can reach and the number of hops, routers, required to get there. As a result, each router builds a routing table based on this information, choosing the routes with the fewest hops to reach each destination.
Gud vad du är tråkig. Ja, jag sa det. Jag har inte ändrat mig. So I said I fix a thing on the dishwasher. And my hubby's like, you said you would fix that today. Yeah, is the day over? No. And I told him about this ticket thing. And he was like, that's when he started talking about the dishwasher. I'm like, dude. So I'm thinking they've covered this from another of the rooms. So let's just fill these in. I don't need to do capital letters because it will change it right when I click. Yeah. So I think I like that. So I'll just copy this, and in our new section network here, where we put side model and TCP IP, we're going to do routing, and I'll just paste these, and let's make a comment to Sham. So there. So we have the source for it. So I'm not stealing anyone's stuff because I'm not going to rewrite that now. Or Google more, even though I might want to. Not. So there are too few IPv4 addresses. But we can use one on public, money private. Yeah, so people like net now, even if there were addresses, which there are, right? V6. It's less the thing too with people are like, yeah, but change. We can change things, right? That would be work. So what time is it? Yeah, so I'm going to make a quick call. I think I will actually go outside in the room. I'll be right back. Let's just we're almost finished with this one, right? Not supporting records, generally private IP range, digital laptop established connection web server, IP TCP port, however, same connection established TCP port. So whatever. In the network diagram above, what is the public IP that the phone will appear to use when accessing the internet? We can't copy stuff here, so I'll have to actually type it. 212, 3, 4, 5. Maybe it wasn't that hard. 1, 2, 3, 4, 5. It wasn't that hard. Assuming that the router has infinite processing power, approximately speaking, how many thousand simultaneous TCP connections can it contain? Oh my god. I guess we're going with 65 again, 1,000. Since that's the number of parts. This room introduced various protocols that we constantly use, directly or indirectly. So this is where we're going to click View Site. Which protocol do we need? As we have learned in this room, different protocols and techniques are used to solve various problems. In this exercise, we will help this computer get the information it needs. For each question, we need to select the protocol that best helps answer the question. So I've had problems with these things not working, so I really hope it works. I want to confirm that I can exchange packets, but it's new, right? So it will work. Exchange packet with a host, as if I am playing ping pong. Oh gosh. Come on. I want to find another host's hardware MAC address. ARP. I want to obtain an IP address to use and communicate with other hosts on the network. DHCP. I'm curious about tracing a road of packets as they travel to their destination server. So you have a flag. Copy. Paste. Submit. Computer is happy. Very cute. And when we click this one, we will hop to the next one. And there was no box started, so the first time I remember it. Also created 1 day ago. So fingers crossed. Nothing. Nothing new at all.